Waterproof fabrics are fabrics that are inherently, or have been treated to become, resistant to penetration by water and wetting. The term waterproof refers to conformance to a governing specification and specific conditions of a laboratory test method. They are usually natural or synthetic fabrics that are laminated to or coated with a waterproofing material such as rubber, polyvinyl chloride, polyurethane, silicone elastomer, fluoropolymers, and wax. Examples include the rubberized fabric used in Mackintosh jackets, sauna suits and inflatable boats. They are even used for footballs and glasses. Design. Alternative spellings include waterproof breathable, and waterproof breathable. Waterproof breathable fabrics resist liquid water passing through, but allow water vapor to pass through. Their ability to block out rain and snow while allowing vapor from sweat to evaporate leads to their use in rainwear, waterproof outdoor sports clothing, tents, and other applications. Standard laboratory testing protocols define the performance of these fabrics. Water resistance is measured by the amount of water in them, which can be suspended above the fabric before water seeps through. Breathability or moisture vapor transmission rate is measured by the rate at which water vapor passes through, in grams of water vapor per square meter of fabric per 24-hour period, often abbreviated to just G. In recent years some, but not all, sporting goods manufacturers have begun including this information on their product labels. Typical mid-range fabrics tend to have values of 5,000 mm of water resistance and 5,000 G of breathability. The best materials have 20,000 mm and 20,000 G. One specific definition of waterproof breathable requires the fabric to withstand over 1,000 mm of water pressure without leaking. These values should be taken with some caveats. Rainroom tests show that some fabrics with less than 1,000 mm of water resistance keep water out sufficiently for practical purposes. Garments made from these fabrics tested in the Leeds University rainroom show no signs of leakage after 4 hours of simulated rain 5 times heavier than heavy British rain. However, some garments made from fabrics that exceed 20,000 have leaked through zips, hoods, and seams. Pressure may not be a good measure for rainwear, as the force of the raindrop on the fabric also depends on how much the fabric moves. It is a good measure for sitting on wet ground or similar situations. In addition, the breathability of nearly all waterproof breathable fabrics is very dependent upon weather conditions, especially temperature, humidity and wind. Fabric construction which directs water away from the body, rather than membranes, coatings or laminates, can be used to keep the wearer dry. This means that perspiration can be moved away from the body more effectively, as both liquid water and water vapor can be directed. These are directional fabrics such as Nikwax Analogy and Furtek, which are also breathable in the conventional sense. Fabrics can also be waterproofed by a spray, although this might alter the properties of the fabric. Garments that combine waterproofing with some thermal insulation, such as those manufactured by Furtek and Nikwax Analogy, resist cold bridging, heat transfer through layers of poorly thermally insulating materials in close contact that would be prevented by a small airspace. When there is cold bridging, vapor on the dry side can condense on the cold surface, making it appear that the thin waterproof breathable fabric has leaked. Also, not all waterproof fabrics are used for clothing. The demand for stain and waterproof fabrics is also high in the upholstery industry, where products like Krypton find frequent application on sofas, chairs, and pillows. Their waterproof nature also makes them highly resistant to bacteria, making them suitable for settings like hospitals as well. See also, durable water repellent, layered clothing, sauna suit, waterproofing, Hipora, Gore-Tex, Ventile, Nikwax Analogy, Decor. References. External links. Breathability comparison of commercial outerwear shell layers, Phil Gibson, 2000, Materials Science Team, United States Army Soldier Systems Center, How to Waterproof a Boat Canvas Waterproofing CC Article 2013.